Hold heads, heads, tails. Heads fixed and move the probability of heads. The teal curve is the likelihood. Its peak is at 3/4. But one curve can answer several different kinds of question. A likelihoodist asks which parameter values this observed curve supports. A frequentist turns the peak into an estimator and studies repeated datasets. A Bayesian combines the likelihood with a prior to form a posterior. They begin with the same curve and construct different claims. Likelihoodist, frequentist, and Bayesian are not positions on one line. They ask different questions. Same model, same data, same likelihood, different inferential objects. A likelihoodist keeps the whole curve and reads relative height. The relative likelihood formula divides each height by the maximum, so the peak becomes 1 without changing any comparison. A horizontal line can mark values with substantial support relative to the best fit. That support region describes this observed curve. It is not a probability distribution over the parameter. Compare 1/2 with the peak at 3/4. Divide the likelihood at 1/2 by the likelihood at 3/4. The result is about 0.59.
Does that make 3/4 true?
No, relative support is not certainty, and it does not validate the model. Why keep the curve instead of only its peak? The peak gives one location. The curve also shows which nearby values remain competitive and how quickly support falls away. Compression is useful only when we remember what it discarded. Turn the likelihood peak into a rule, dataset in, maximizing value out. That rule is an estimator. The compact formula says to choose the parameter value that maximizes the likelihood for the dataset before seeing data. Its answer is random because the data are random. Frequentist analysis asks how this rule behaves when the experiment is repeated. Fix the true coin probability at 0.6 and generate 12 flips. Record the sample proportion, reset. And repeat. Each dataset gives a different peak. The yellow cloud is the estimator's sampling distribution across repeated datasets, not the likelihood from one dataset. Does the cloud center on the truth? How widely does it spread? Those are bias and variance questions about a procedure. They cannot be read from one observed likelihood alone. A Bayesian adds a prior distribution for the parameter. The blue curve favors moderate coin probabilities. Multiply it by the teal likelihood. Bayes' rule divides that product by its total area. So the normalized yellow posterior appears. The posterior, unlike the likelihood, is a probability distribution over the parameter. The likelihood peak gives the MLE at 0.75. The posterior peak gives the map near 0.67. The posterior mean lies near 0.625.
Which point is the Bayesian answer?
The posterior is the answer. A point estimate is an additional summary or decision. The prior changes the posterior, not the observed likelihood. It contributes assumptions and information from outside these flips. One likelihood can support direct evidence, a repeated estimator, or a posterior update. The mathematics overlaps. The claims do not.